Welcome everybody to this evening session with with Engineers Ireland. My name is Dennis Kelly. I'm on the EECA committee, and I'm just kicking off the session. I'll be doing some facilitation. We're delighted you're joining us this evening for the session with Green Rebel. For those who don't know, Green Rebel are a Cork-based technology company founded by Pierce Flynn, and the CEO is Kieran Ivers. The company's focuses on offshore services, particularly geophysical and metocean research. They provide a very wide range of services. They have some really interesting technologies, whether it be LiDAR or on their vessels. But they also do some really fantastic work, taking that data that they collect at sea and then packaging it together into services that we as engineers need to build our offshore developments, be they oil and gas, or probably more appropriately at the moment, the whole construction of offshore wind, be they fixed bottom or floating. So it's with great pleasure tonight that we'll be meeting two of the key players with Green Rebel. That's Kevin O'Leary and Cian Ryan, who are going to talk to us over a kind of a two-man presentation. The format will be the two presentations, and then at the end it'll be a Q&A. During the session, if you'd like to ask a question, please place your question in the Q&A box, which is at the bottom of the screen, not the chat box. Please put it into the Q&A, and I'll collect the questions as you go along, and I then facilitate the questions to both Cian and Kevin. So without further ado, and to get you started, guys, I'm handing over to Kevin and Cian, who'll take it from here. Thank you very much, guys, and welcome.
Thanks, Dennis. Cheers. Hi, everyone. Okay, look, we'll get straight into it. So thanks for having us, first and foremost. So look, my name is Kevin O'Leary. I'm actually a chartered engineer with Engineers Ireland, and I'm one of the senior operations project managers here in Green Rebel. So my background is in structural engineering, and I've spent some time working in, let's say, the the water and gas industry, some of the pharma sector, and then I found my way to Green Rebel for the last almost 3 years, and have been involved in a lot of geophysical projects, and more recently, the full portfolio for the metocean division. So I'll hand over to Cian there now.
Hi everyone, my name's Cian Ryan. I'm also a project manager in Green Rebel, but I kind of work on the geophysical side. My background is in sustainable energy engineering, and I've been managing surveys for Green Rebel for the last just over a year, geophysical, geotechnical and cable route surveys. I started out as a mechanical engineer in mechanical engineering and construction, moved into utilities and infrastructure, and then eventually into the green hydrogen space, and now most recently into Green Rebel. And I might just go through the agenda that we have this evening. So we'll do a very brief introduction to Green Rebel. We'll take the offshore wind project life cycle and what Green Rebel's role is in that, and where our services are. We'll take the geophysical services and go through those and what we offer and where they apply to the engineering. We'll go through a little bit of engineering at Green Rebel and vessel mobilization, and then it'll be over to Kevin to take us through metocean services and those data applications. And then we'll take you through the engineering and PM challenges that we face, technology and innovation in the offshore space that we've been undergoing at Green Rebel, and then, as Dennis said, the Q&A session at the end.
Very good. Okay, so just a brief introduction to Green Rebel. So as Dennis said, that look, we're basically a data company, primarily trying to basically aim for data acquisition and then process the data and provide a data product to our customers that will make informed decisions across primarily the wind industry. But we're a Cork company and definitely proud of that. HQ is in Cork City. We've offices in Crosshaven and also in Limerick. We've around 75 to 80 specialists across multiple disciplines, and Pierce Flynn is our founder, who's very ambitious and is keen to grow the company across Europe and further. And we have a fleet of vessels, specific survey vessels, and high-tech, I suppose, in high-tech buoy products for data acquisition. lead us on to our processing stages. So again, as Cian will probably mention, like we're very lucky, Green Rebel, while it's a startup and it's growing, it's the people that make it. So we're very lucky to work with multi-talented people across engineering, project management, and more impressively, I think that the data side and the processing and the analysts are amazing, and the products that they offer to our clients, I think, is extremely impressive, and it's something we're certainly proud of. So that's just a brief introduction to Green Rebel. Okay, so here we have the kind of the offshore wind development timeline, and this is there's many iterations of this sort of process flow in terms of a life cycle for a wind project, but we're trying to simplify it as much as possible for everyone, and this seems to help internally. So we've 6 steps here where we kind of go through the process, Green Rebel's offering, and then the deliverable associated with that step. So the first one here is kind of the concept design, and what Green Rebel like to offer is kind of some consultancy, but also I suppose the key deliverables that we input into is like the historical data is one, but more importantly from the metocean side is the wind resource assessment, which is a really important assessment for our clients, and also desktop constraint studies across our geophysical and metocean clients. So again, we'll speak about this later on in more detail, but certainly an area where our metocean division is extremely, I suppose, present in. Again, we're very present in the stage 2, which is preliminary design, where the metocean geophysical data plays a huge part in terms of our clients' business cases. It dictates kind of in terms of lending capabilities and limitations, and also things like EAR, foundation design, turbine design, UXO clearance, and ground modeling. All the data we provide our client has a huge input into decision-making analysis, and I suppose moving the project on to the next step in terms of de-risking and ensuring that the project moves into its feed and detailed design stage. So on that point 3, this is again more refining, be it the array layout, turbine size, foundation designs, foundation strategy, any of the cable route criteria, and definitely looking at de-risking the overall project in terms of the more data they get, the more accurate, high quality data they get, the better informed decisions they can make. And it leads to probably more chance of success by de-risking and mitigating as much as possible. So as well as that, we can lend, I suppose, a hand and support in terms of construction methodology, in terms of our surveys, looking at ground truthing, and then identifying any subsurface hazards that may be in the area. So again, we have a brief kind of input into the planning section, where again consultancy and sort of our environmental data products are helpful here with the EIR especially, and then we provide also expert opinion based on our experience to date with some of the specialists we have internally. Just next steps here is the construction stage. So again, we're looking at this area more as obviously Ireland is a little bit behind the curve in terms of the construction stage, but looking further afield, we see we have a good offering in terms of assisting and supporting in terms of environmental data. Certainly we can see we offer product to a number of clients in terms of barge and sediment monitoring around outfalls or any dredging or any kind of earth removal scopes. And also we provide, say, security data or weather data across, say, a live project. We have quite an array of products in the metocean division, and we also have our vessels on site. It could be potentially on site as well to assist with pre and post laying cable surveys. And finally, on the O&M side, which is definitely further down the line for us, but hopefully in the future, Ireland will look like we'll have more live wind farms, and especially across Ireland and the UK, we can see that there's a large potential for that. And again, we support this with what we just previously mentioned in terms of environmental data, barge and sediment monitoring, weather, and any of the more intricate cable inspections across any of the routes. So this is just to kind of give people an idea of where we see we're trying to explain a process where Green Rebel's input is and how we can contribute to some key deliverables. And the big thing here is we want to get across is that the data we provide is to assist decision making and definitely de-risk the project as much as possible for our clients. So we'll bring up these later on in the presentation. So you can go ahead.
Yeah, and interestingly, Kevin, we've kind of come full circle in Green Rebel. So where we were doing kind of preliminary geophysical surveys offshore in Ireland, currently our vessel Roman Rebel is doing in situ cable inspections in Germany. So we're now kind of surveying in the O&M space. So we've gone from the very kind of prelim stages of design right through to O&M, and it's interesting to see, you know, the vessel surveying past turbines and offshore substations. So it's hopefully a sign of things to come for Ireland.
Yeah, absolutely.
So I'll take you through the geophysical survey services. So that's one side of the division, and Kevin then manages the metocean side, so he'll take you through that as well. So I suppose as Kevin mentioned, the data that we use informs decisions and de-risk. So I suppose down the bottom, what essentially are we trying to do? We're trying to identify hazards for our clients through our surveys. And then by identifying those hazards, it allows our clients to make informed decisions and mitigate risks. So whether that be identification of UXOs or boulders, etc., they can design around that. And then also, I suppose, assist with kind of cable route development as well. So whether that be an export cable corridor for a wind farm or a fiber cable across the sea or an interconnector, I suppose our data can assist with route development. The life cycle up at the top, I suppose. So what do we go through in the geophysical survey? So I suppose there's maybe one step missing at the start, and that's planning and mobilization, which is a lot of where the kind of engineering works happens for me. And then acquisition, which is actually acquiring the data, processing that data, similar to the 3D representation of multi-beam data below, which is in the form of a point cloud, and analyze that data and then interpret it, report it, and create an interpretive report and then deliver it to the client. And then also ensure that we have adequate workshops with the client to ensure that the data is fully understood as well. So what does our fleet look like? We've 2 vessels currently, and we also do charter in vessels ad hoc as well, depending on demand. So first vessel we own is Roman Rebel, 27.5 meter vessel. So this is a 24-hour work boat. Even has a chef on board. So the vessel is self-sufficient and can go to sea for about 7 to 10 days. And then the vessel on our right is our vessel that does inshore works. It's a day works boat, so works usually kind of 1 12-hour shift. That's the Lady Kathleen, was launched in 2021. Much smaller than the Roman Rebel, but equally it allows us to do kind of smaller inshore surveys where there's shallower waters. I'm just going to take you through each kind of each data set that we acquire. Now, there's other data sets we acquire, but these are the kind of main data sets that we acquire currently. I suppose so. Multi-beam echo sounder. This is a hull mounted sensor. So we are essentially determining the water depths and any kind of features in the seabed. So you can see on the right side sediment ripples. So the outputs that we can get from this is bathymetry to any IHO standard. We can get GIS deliverables, contours, seabed classifications, gridded data. And then I suppose, why do we acquire multi-beam? So we create a high resolution digital terrain model, which allows decision making and inputs into design. We can do backscatter, which gives an idea of seabed hardness and reflectivity. So is it sand? Is it mud? Is it exposed bedrock? And then also there's engineering value. So we can spot hazards in there, shipwrecks, boulders, debris, exposed bedrock. And then also we can derive slope from this as well. So if you're putting down a jackup vessel to do boreholing, or if you're doing kind of even lighter geotech like CPTs, we can identify where there might be extreme slopes where you may run into difficulty. The next sensor we use is another hull-mounted sensor, so it's actually fastened to the hull of the vessel, and that's a sub-bottom profiler. So multi-beam will give us everything above the surface, whereas this will give us subsurface. We use an Innomar medium on the Roman Rebel and a standard on Lady Kathleen, and we can get penetration of up to 70 meters. But again, this is geology dependent, so depending on overburden. So typically what we produce is high resolution profiles to 10 centimeter vertical resolution. We do interpretations, so picking horizons, isopacks. We create GIS deliverables like such as isopacks. So I suppose, why do we collect this data? Bedrock tracking, so trying to aid in foundation design for turbines and substations. Another risk is shallow gas seepage. We can identify shallow gas seepage and de-risk that for clients. And then there's also subsurface geohazards, so channels, faults, and buried infrastructure. So as you can see on the right side, a paleo valley is showing here in the data as well. So allowing our clients to de-risk those hazards as well for foundation design. And then I just move into the towed sensors. So we tow these out the back of the vessel. A side scan sonar. So you can see here in the image on the right, it's a shipwreck, and you can actually see the shadow of the mast from the shipwreck, as well as a trawl scar on the right-hand side. So what this does is it gives very high resolution imagery of the seabed. So picking out boulders, with what we call target lists. So boulders, shipwrecks, any archaeology as well. So that feeds into the planning process as well. So any underwater archaeology that may be within a client site. We can do high and low frequency mosaics. And then we have derived data sets based on that. So I suppose, why do we acquire this data? Again, hazard identification above the surface and mapping. So we classify the seabed, so which helps route engineering for cables, and also we can determine possibly depth of burial and plow loading as well for when they are actually installing the cable. And then another sensor normally that we tow behind the side scan in what they call a piggyback formation. So it's just basically one towed behind the other from a winch. So we use ultra short baseline positioning as well. So we put a beacon onto the side scan so we know where it is. What we're using the magnetometer is to find first objects, unexploded ordnance, shipwrecks, or any kind of infrastructure that's there. We can also assess the magnetic residual field and complete UXO clearance. So very important for if a client is going into do kind of any construction activity or any kind of use of jackup vessels, whereby, Irish Sea, North Sea, there may be unexploded ordnance from either Second World War or First World War. So the applications, so again, UXO, shipwrecks, so construction risk mitigation or kind of any very invasive further survey that they're doing. And then also, I suppose, when we run the mag over any kind of infrastructure that's in place, like cables and pipelines, it's just ensuring that they are actually in the correct position as charted. And what we get is kind of red targets, such as the image on the right. So that allows the client, say, if they're doing a cable routing exercise, if they're completing a crossing of that cable, they will know exactly where it is based on the mag data set. So, and we can cross-reference that with the sub-bottom profile imagery as well. And then lastly, UHRS. So this is similar to the sub-bottom profiler, but I suppose it's lower resolution, higher penetration. So at the bottom, you can see a data set below from the UHRS. We normally team up with a specialist subcontractor. We can offer single channel UHRS, multi-channel, both 2D and 3D. We've recently completed a 3D survey this last year. So we'll get deep penetration profiles. And again, why do we do this? It's same kind of applications as sub-bottom profiler, trying to find shallow gas, tracking bedrock, and that all feeds into the foundation design. The 3D UHRS, what that helps is determine subsurface hazards such as boulders below the surface. The image shown here is a 3D spread being towed from the vessel, and this is a project that was actually managed by Kevin.
Yeah, so just to kind of recap, from our client base, we're kind of used to seeing the request for single channel, and then I think 2 years ago it was multi-channel, just to kind of increase I suppose the offering. But lately we embarked on our first project on 3D and 3D UHRS, which was a huge success. Now the picture and the image on the screen doesn't give you a good idea of how congested the vessel was, and it was. As Cian will probably talk about it later in terms of the challenges of mobilization, but we're certainly seeing that our clients are looking more to 3D UHRS as a deliverable and an output. And the reason is because we spoke about it briefly, it's de-risking their design. They're spending more money early, but they're getting way more information at an earlier point of the project to make those informed decisions. And as Cian said, the early boulder detection, subsurface boulder detection, can really save, because the product in 3D will give you real accurate data. And what will happen is it'll actually reduce the need for geotech campaigns further down the campaign, because you already have accurate information. And that's proven to be quite an attractive offering. So yeah, I think it's worth noting that the 3D UHRS is definitely something that's probably not going to be here for the future.
And just to kind of take you through, as Kevin mentioned, I suppose mobilization is where a lot of the engineering work goes on for us. I suppose you're conscious that what we're doing a lot of the time is actually creating data that feeds into a design for a client to allow them make engineering decisions. I suppose we do our own engineering works as well. So the image on the bottom right here shows a vessel called Glomar Vantage, which was gearing up for a fiber cable campaign where we were doing geophysical and geotechnical surveys. So basically the vessel comes as a blank canvas, as I like to say, and then you have to fit out all of the sensors, and basically we underwent 2 mobilizations and 2 demobilizations. So just to give a kind of flavor of the mobilization in itself, this is a very rough drawing on the top left. But I guess you have winches, various winches, cables. You've got vibrocores. We had CPTs, all requiring power supplies, fabrication, and then all requiring, they had various fleet angles, etc. as well that we needed to adhere to. So quite a lot of planning goes into this, about 8 weeks of planning while we were in the middle of a geophysical campaign. And you can see in the image as well, there's actually a moon pool on this vessel. So the CPT, which is the yellow unit in the bottom left, is actually lowered through that kind of trap door almost, and goes all the way to the bottom, pushes a rod, and then is retrieved back up. So this is kind of an image just showing and the mobilization, basically whereby the guys were tuning up the CPT, which is the yellow unit, and the grey unit above is a constant tension winch. So there's an umbilical goes on to the CPT, where there's data transfer, and then you also have a lift wire. So there is a lot going on in this. I suppose you're designing the back deck layout specifically for this purpose. You've life critical safety systems, so the guys will have to have available points where they can harness on, and those points all need to be tested as well, load tested. You've got to load test all your sheave blocks, etc. as well, to ensure that the A-frame and the sheave blocks can take the load that is being applied to them. You've got fabrication works. We were very lucky to have a local fabricator in Cork who's fantastic. And it's all kind of bespoke fabricated items. So lots of measurement. And I suppose this vessel was in Holland, so we had to go and visit the vessel and actually measure up and install everything. Then there's a lot of electrical install as well. And then we have to fully fit out a survey lab. with our own IT equipment, racks, uninterruptible power supplies, Starlink, so that we can transfer data off the vessel every day. And then we have to fit out either the sensors or the geotechnical equipment as well. Dimensional control survey. So it's basically a point cloud model showing where each sensor is, and it's offset in relation to the vessel itself, or the positioning aerials. Geotech equipment install, as I discussed. And then also we need to, once we have all this completed, we need to develop safe systems of work. It's quite a pressurized stage of the project. Usually takes about a week, and you could be planning anything up to 3 months just to mobilize, because I suppose commercially the vessel is there, you're paying for it, and you're paying for all the people to be there. So it's a really kind of heightened program, and a lot of planning goes into it. And the more you plan, the better it works out. Might just hand over to Kevin there for the
Yeah,
metocean side of
so
things.
thanks, Cian. I'll just take everyone through just a kind of a brief stop, run through the metocean services and any of that application. So yeah, we'll run through the boy there now. Okay, so first of all, so like, what is the end product from the metocean point of view? I'm just going back a few slides there to the concept design, the preliminaries, which is where we're focusing on from a metocean point of view. And the offering here in terms of an end product is wind data, wave data, current, conductivity, temperature, pressure, precipitation, motion compensation, and any environmental data. So there's a lot that we try and acquire when we have the buoy in the water. There's a lot of processing involved, but at the end product, you're getting quite a lot out of it. And this again leads to what we said, de-risking, presenting this to our clients so they can make proper informed decisions. So Cian, we'll go on to the next slide. So again, just some history lesson on the metocean vision. So one of the directors here, John Wallace, he left the Marine Institute and started a company called IDS Monitoring. And his mission was to develop and deploy to support autonomous data acquisition platforms. And you can see there on the bottom right is a metocean buoy, which is a DB180 model, which is kind of John's, I suppose, one of John's main products, and was, I suppose, the point, or the starting point of where we were going to develop this and I suppose improve it to the next model. But this is called DB180. The one on the left is more of a different type of product. I think this is deployed 1997 off southwest coast and the Fastnet Rock. And this started was the development of IDS and scaling the business to the DB180 model, as you see on the right. As you can see there, John has been involved in the team of over 300 projects across 20 countries, and has been running since 1990s. So we move on. We'll discuss Green Rebel's input here. So Green Rebel came on the pitch and acquired IDS monitoring, and the idea here was that we as a company needed to provide a solution to suit our client needs. And what we noticed was we needed to produce a product that was bigger, more powerful, better redundancy, better battery life, better reliability, and was able to withstand, I suppose, sea conditions that were miles and miles and miles off the coasts. And what we see here is that the durability was a big factor, as we have kind of range contracts from 12 months to 24 and sometimes 36. So the idea here is that we needed a bigger, robust product that was reliable. So on to the next scheme. So just these are probably the next slide is probably a bit more detailed, but just to run through, this is the image of the buoy on the right, just in a 2D drawing. So again, just some 24 tons of gross buoyancy. The actual buoy itself is 12 tons, and with a total net buoyancy of 12 also. The idea here is that the big selling point is the redundancy of power systems. So there's battery bank A and battery bank B, two independent power sources. And we're also currently installing battery bank C now, which is another backup solution also. We previously had kind of E5 fuel system cells for this, but we decided to move away from this as our client needs, and in terms of environmental impact and also health and safety, we've moved to lithium-ion battery solution. So again, you'll see in a couple of the images that the trunk of the buoy is covered in solar panels, and also there's two turbines on the crown, and these are ran through a charge regulator panel to charge the batteries at all times and keep them topped up throughout the campaign. So just to give kind of frame in people's minds, if you go on to the next slide, Cian, just the kind of size and scale of the buoy. So just some kind of key items of the product. It's made from polyethylene, aluminium, and steel. There's certain navigational equipment to aid in navigation when it's at sea, in terms of obviously the color, and there's LED lanterns. There's also an internal GPS system. The weight of the buoy, as I said, is 12 tons. Overall height is 7.34 meters with a diameter of 4.7 meters, so it's quite large. As I said, the solar panels are producing most of the power and topping up the battery banks with the lithium-ion battery. Yeah, it's the redundancy of having battery bank B and C is really starting to pay off across our buoys, and certainly ticking that redundancy box. But I'll move on to the next slide where we'll speak about some of the sensors that are on it. So key to the floating lidar buoy is the ZX lidar, okay? And this is a wind measuring sensor that's based in the internals of the buoy facing upwards, and it captures 10 to 12 readings from 0 to 300 meters altitude. So it's constantly recording and measuring heights of wind as set by the client and ourselves. And that's I suppose that's the key item on the buoy for our clients. Now, we offer a single and double solution, which we offer one, which be measuring variable heights from the 0 to 300 meter altitude, and the other one could potentially be fixed height at what the client may want as the fixed hub height. So trying to offer a different range of data sets for a client to help those decisions again. But real-time data is something that's becoming extremely, I suppose, important to clients, and like 10-minute data, 1 second and 50 hertz data you can see here. But John and the team here, we have an internal product where we can log into the buoy and see live data coming online any day of the week, 24/7. So it's very powerful. It's something our clients are looking for more and more, and we're able to provide that solution with the dual lidar and single lidar offering. So again, we partnered with a company called ZX Lidar since 2018, and we use their products across most of our projects. So it's been quite successful to date, and certainly the dual offerings are becoming more popular. So on to the next, Cian. Yeah, so this is just a recap, okay? You can see the two images of the buoy on the right. So in terms of the actual floating lidar instrumentation, the standard offering here is that we have the ZX Lidar 300, or we have another product also, which is a Vaisala WindCube, which is available single or double. We have a wave sensor that's mounted on the FLS that measures waves. The ADCP, which is current, which measures current and depth, and that's an Arctic Signature Series sensor. And we also have a fleet of meteorological sensors like AirMars and Vaisalas that are based on the crown of the buoy to help with direction and any atmospheric conditions to be recorded. We also offer additional kind of support sensors, which would be standalone directional wave buoy unit, which is independent of the actual product you see on the right. And similarly, another independent sensor or product would be a kind of an anti-trawl resistant seabed mounted station, which will have an ADCP and a CTD, which is current temperature, and yeah, a single point current meter basically, which measures conductivity, depth, and temperature. So yeah, that's just an additional offering that we kind of accompany with the main product, the floating lidar buoy. So it'll be a way. There's actually an image in the next which might show it a bit better. So if you move on, yeah. So here you can see just this is the overall kind of floating lidar system. So I'll just work from left to right. So you can see here is an option which is a hydrophone, which can assist with our clients' need in terms of marine mammal monitoring and kind of understanding the underground or sound baseline. The next item there you see, which is the yellow object on the surface of the water with a small mooring, is the directional wave buoy, and this is just to, I suppose, accompany the main buoy to ensure that we're gathering accurate and we're supporting the wave data. The next item below on the surface is the first mooring section, the first sinkers of the mooring. The yellow, or sorry, the red item then, the red line, that's ground chain. The blue line attached to that is Dyneema rope. And then the top section there is top chain, and the red line. Then you'll see the orange section below that on the surface is a seabed frame, which is facing up. So that's the ADCP facing upwards for measuring wave height. And you'll see the buoy structure in the middle on the top of the surface, which is actually has an ADCP facing downwards. So we've got redundancy there as well. The buoy itself, you can see that the LiDARs are facing upwards, and they're measuring sort of a rose cone shape, gathering data across 10 to 12 measurements, as we said previously. And again, you can see that on the right-hand side from that, there is the top chain, the Dyneema rope, and the ground chain finishing with two large sinkers. So that's the overall kind of summary of the system. This obviously is a two-leg mooring, but we offer other solutions also. So that's just to give everyone sort of an idea that the buoy is the main product, and we have 2 or 3 other items that would supplement kind of a redundancy in terms of the wave and current. So again, just to give people an idea of the typical buoy, say that the project life cycle. Step 1 here is just a project initiation, where we would focus on sort of ensuring our contract and scope is correct, setting up our internal team, setting up the timelines, and then delivering the project as per the schedule. Again, step 2 is the project planning, like everyone probably is well used to here. It's heavily involved in documentation, meetings, progress updates, and just tracking progress and reporting back to our clients. And step 3 here is the build, install, test phase. So as you can see in the image, this is our workshop in Limerick, where we have 4 hulls there in the picture. And this will go through sort of a rigorous workflow where everything from cabling, the sensor installation, we have charge regulator panels, data panels, power panels, the LiDARs, all spares, all solar panels, and the crown, all the sensors like the Vaisala unit, the AirMar unit, the nav lights to any of the yellow crosses that we put up for identification. That's all done internally in the workshop. That goes through a sort of build and install phase. Then it goes through a testing phase, which we follow sort of, this section is a factory acceptance testing. All the products that we put on go through a rigorous factory acceptance testing checklist, and they're signed off and moved to the verification stage. So when we speak about verification, the LiDAR itself needs to be verified. And we have a site in Leg in Netherlands where we use a third-party company to verify the LiDAR. So what we usually do is we deploy this on our site in Leg. It usually stays there between 6 to 10 weeks. And the LiDAR is constantly operating, as well as other sensors, in sort of a trial basis where we're getting live data back. We send the data to a third-party specialist. They analyze it. And what the LiDAR has to do, or the LiDARs have to do, is they have to populate certain wind speed bins across the duration. So there's 40 bins that have to be filled across, say, low, medium, and high wind speeds. And once they're completed, the verification is reviewed, signed off, and completed. And it means the LiDARs are within an extremely high accuracy, and they're ready for site. So once that's completed and we get the notification, we recover the buoy at Leg, we transport it back to Limerick, or else to the port that's selected for deployment. It goes through sort of final fixing stage. It goes through a PAT testing, which is port acceptance test. That's signed off by the team, and then it's ready to go for deployment. Step 5 then is the deployment, and as you can see in the image here, a big part of this is, as well as the buoy, there's the procurement of all the mooring items, the chain, the shackles, the sinkers, the Dyneema rope, or the swivels. So there's quite a bit in that, and we need to get everything, I suppose, all the logistics planning that gets the buoy, any of the ancillary products, and the mooring to our port. It goes through a full inspection in the port. Again, the dry run testing, system testing. The mooring runs through its own independent port acceptance test. And then once all that is signed off, the vessel is booked to come in. It collects the buoy, it mobilizes either in a towed operation or a lift operation, and then it's deployed on site in terms of its coordinates. We move into the O&M stage where we have obviously the service vessel there to the right. So we have planned services, and obviously there's the odd reactive maintenance visit. So that's ongoing for 12, 24, or 36 months duration. And usually it's trying to go every 6 months just to do a visual inspection, repair any damaged items in terms of storm damage, and do a bit of a health check or data download. And then a repeat of kind of the opposite of step 5 and step 7. We recover the buoy, pull the mooring, the buoy, and all the equipment, and bring it back ashore for cleaning, demobbing, and then it gets ready and prepared and put into a workflow for the next project. So that's just kind of a brief tour of a typical project life cycle for the buoy. So I go on to the next one. So again, just to give people an idea of the portfolio over the last 2 years. So we've seen a lot of growth. As you can see here, we have a presence in the west coast of Ireland. We have 2 projects in Scotland, 1 in the UK. We have 2 buoys in the German Bight, and we have our site in Leg in Netherlands as well. So we've seen quite a bit of growth. We've quite a few projects out there at the moment. It's interesting that like the Scottish projects and the Irish projects, they're in very harsh conditions, and the buoys are performing very, very well. So a few slides back, the target was to create a robust product, and I think we're certainly hitting our targets. And more interestingly, we've survived a lot of the recent storms, but it's certainly topical as it's certainly changing our mind in terms of designing moorings and designing connections, because what we're seeing, and we'll touch on it later, that the storm events that you would typically design for are now not enough. The 1 in 50-year events are being completely surpassed by some scary storms like what we've experienced in the last couple of months. So again, big focus internally on continuous improvement. There's always learnings, and there's always, especially as a young company, we certainly rely heavily on our lessons learned workshops and our continuous improvement initiatives. And we're certainly improving our offering, and that's being seen in the data we're seeing across the portfolio. And most of our clients now are seeing that the dual LiDAR is certainly our most popular request. So yeah, look, better data, better decisions in terms of the product here. So I know we spoke previously that look, we touched base on the wind resource assessment, the investment inputs, the hub height decisions, the turbine array, turbine height, blade design, foundation design info, the scour impact for fixed turbines and moorings, survey requirements for any of the construction phase or O&M phase, construction planning for any of the monitoring or security, material selection for the foundations, and then an O&M strategy. So the data we provide is, I'm probably missing quite a few there, but it's extremely important, and it's the quality of our data is the most important thing. We see a lot of requests for getting the speed of data to our customers, which is of high importance, but the quality is paramount, as it will have a huge impact in terms of the projects and how it will be financed in the future. So we're really seeing that the high quality product that we're providing is certainly, I suppose, of extreme importance to our clients at the early stage of their projects. And the whole here is that we're trying to de-risk the offshore projects as much as possible, but with a keen eye the whole time on innovation and the improvements in technology. And you can see here on the right, we've got some kind of windrows diagrams in terms of wind direction, which are very important and are part of our monthly deliverables. We've some wave data here at the bottom. We've some depth data as well, and again some wave comparison. So that's just a flavor of what you can pull from some of the reporting. And there's some, especially recently after the storm, we've pulled some incredible data from some of our products, and it's certainly opened our eyes, as I said previously, to our design parameters and our design life, especially. So yeah, we can touch on that a bit later, but just highlight that the feedback from our clients is speed of data is one, and the quality also.
Yeah, I think it's probably fair to say, Kevin, that like data availability is key for clients, and that reducing uncertainty of what the wind speed and what the wind yield is for their wind farm. I suppose it kind of feeds into the techno-economic modelling of the site as well.
Yeah, absolutely. And the key factor here is the reliability in terms of the dual LiDAR proposal, or the redundancy we have in the metocean product is extremely important, because you are placing these in extremely harsh environments, and they are experiencing record-breaking storms. And there are other challenges with like the fisheries, and even trying to get out to them from a servicing point of view is even a challenge. But yeah, you can move on, Cian.
I suppose I can take some of the engineering and project management challenges, and I suppose this isn't unique to geophysics. It's also for metocean as well. But um, the top one there, the list, I'd say, is survey permitting. It's unique to each country. It can cause delays, and for us, delays means cost escalation, because if you have a large vessel with a lot of specialists on board and specialist equipment, you're paying for that equipment and people on board, regardless of whether you're doing any useful work. So permitting can cause huge challenges in terms of the management of the project. Weather is another key factor, causes downtime, but also there's a health and safety impact as well. Ensuring that we stick to our operational limits, planning the surveys properly as well, and taking in that weather data in real time is key. Um, Fisheries and other maritime users, so you might have sim ops, and also I suppose we need to be conscious that there are fisheries around the coast, whether that be in Ireland or in the North Sea. And I suppose we are kind of interrupting their activity for a brief time, but still, needless to say, we are interrupting their activity. And then I suppose metocean site conditions, so you can have strong currents as well and big tides. That can cause hazards, especially where you're towing sensors, as well as kind of shallow waters as well. So yeah, that's just some of the challenges that we face in kind of managing these projects on a day-to-day basis.
Yeah, and we'll just touch base, as this is an Engineers Ireland presentation. We try and bring it back to some relatable drawing or some bit of engineering. But we in the Metocean division find that the mooring systems are becoming more topical. And as I said previously, we're seeing record-breaking storms, and it's put a lot of attention on how we plan these in the future. So we have 3 systems. We have a single leg here you see in the drawing, which is very, very self-explanatory. It's got like quite a large weight at the end, chain, potentially some dynamo rope, but there's some, and you can add in a kind of float in between. That's the shock absorber kind of a system, but leads up to the buoy, and it's very simplistic design. But again, across all of we'll run through that. There's 2 more, I think, but all our design goes through a naval architect and a structural engineer, and it goes through a rigorous kind of design process. It might seem quite simplistic, but when you're dealing with like you get one chance to deploy this at the start, and you need to get everything right. And that goes down to inspecting every single element of your mooring. Here you see in this image is a double leg mooring, okay? So if you go back one, this is one section of a double leg mooring. As you can see, like we have 210 meters of chain across the ground chain here, and 20 tons of sinkers at one side. So that's 40 in total. As well as the weight of the chain. So we're talking big weight here, and that has a big impact on what vessels can handle what. Again, similar with the dynamo rope and the top chain, but we've added in here a buoyancy module at the top, which acts to keep the chain up to the surface, and kind of keeps it rides the waves better across the larger storms. It just gives the overall system a little bit more buoyancy and protects the actual main product, which is the buoy. So that's a double leg mooring that we're quite used to. This would be our most popular mooring. But we also have, let's go to the next one, so we also have a triple leg mooring here. While you can only see 2 legs, the top right there, you'll see that it's at a kind of a closed feet arrangement. But here, again, this is more challenging, as it requires more chain, more sinkers, taking up more deck space, and has quite a large impact in terms of servicing the buoy as well in the future, where our space is reduced to get closer to the buoy, and kind of hampers or limits our vessel selection. So some of our clients have opted for this, but it poses quite a challenge. But as an overall point, like it runs through a rigorous design. Every shackle is inspected. It runs through a rigorous PAT test checklist, and every shackle, pin, connection, measurement is done on chain, shackles, swivels, everything's inspected, because the last you're going to be doing is going out after a shackle opening and just not being checked properly. So it's of extreme importance to get this right. So the next item here, so this is just an image that accompanied the others. So you can see here the large image on the left is just our buoy behaving on a single mooring. It moves quite a bit. On the bottom right, you can see there's the twin mooring with the two guard buoys protecting the buoy, and also you can see at the top right is the triple leg mooring with the intermediate floats, and you can see on the background of that image the vessel actually moving away from the system. But that vessel is not small. That is a large 90-meter vessel, and it is. We'll show you some pictures in a second. But it's this kind of scale we're dealing with. When I say 40 tons each side or 15 tons each side in the triple, it's a huge weight to move around, a huge weight to plan and organize. And it has an impact on our vessel selection. The ground conditions come in terms of sinking and sort of gripping ability. But you can see here, look, the next challenge is the vessel selection. That's the vessel in question. It's a huge vessel. It's the largest we've used to date on the metocean. You can see there on the right-hand side, okay, they're the two buoys that we deployed, and that's the scale versus our team on the ground. You can see they're in their high vis. That's how big the buoy is. It's 7.34 meters in height, 4.7 in diameter, and it's 12 tons in weight. And what you can see there in the foreground is the weight sinkers. They're 5 ton each, and they are for each leg of the mooring. In the background, you can see the black pallets of chain all stacked in sequence. So there's quite a bit of organizing, quite a bit of lifting and preparing in this, and it's huge weight you're dealing with, which requires bigger vessels, bigger machinery, and certainly bigger cost. So as Cian said previously, with the geotechnical mobilization, there's quite a bit of planning goes into this, and you only get, especially this time of year, you get very brief weather windows, and you have to be ready to go and very much prepared. So there's quite a heavy lift in terms of our man hours goes into this, ensuring that all our subcontractors, fabricators, all our procurement items were delivered, tested, signed off, and the logistics all planned to the port of choice. So these are the challenges, but again, we've, as best as possible, use subcontracted naval architects to ensure we're getting quality design. We have very detailed design reviews, detailed lift plans. Vessel selection goes through a full vessel assurance process and inspection, and then just to accompany all the planning. But yeah, I think I've probably covered most there. Again, this is just some other images in terms of our vessel selection. This is a different vessel used for a slightly different purpose. The previous image showed you the two buoys that were on the deck, and they had to transit out to the German Bight, which is kind of 24-hour transit. This was a towed operation, slightly closer, but still quite a distance out. I think it was 70 miles out, but we decided to tow this, and you can see the guard buoy on the deck versus the actual product itself on the being towed. So these are the kind of the vessels that's a 60-meter vessel, I think, and that's that's quite a decent vessel. But again, what we've learned is this is a large-scale operation. You're dealing with big weights. Sea conditions are extremely important to predict, but also it's at the end of the day you have to stick to your limits, and health and safety is paramount. And the most important thing here is having a competent and well-trained crew, and I suppose just ensuring that we're setting ourselves up for success from the moment the buoy leaves the buoy and mooring system leaves the yard here and is deployed out on site. The big challenge with the vessel, and I know Cian, you'll probably have the same opinion, is that while we have two vessels ourselves and we try and use them as much as possible across metocean and the geophysical division, we often go to the spot market here where we have a relationship with vessel brokers and vessel owners, and we try and use their assets as best as possible because we're familiar with them, we're used to their equipment. But the market is extremely competitive, and once the weather improves, we find it's difficult to get vessels for weather because we're all competing for the same weather windows. But also in terms of pricing and costing, it becomes quite a challenge because it's driven by just the market. So yeah, it's just a few of our challenges. Next item there, Cian, I think is fisheries. Yeah, so again, as Cian mentioned briefly, fisheries is always there, and it's an important factor in all our projects, no matter where we go, whether it's geophysical or geotechnical or the mid-ocean product. We try and do as much analysis as possible in terms of fishing traffic, in terms of the vessels. We try and work with fishing liaison officers as much as possible to get us the live information in terms of any of fishing assessments or any of the potting assessments that were done, just to ensure we have the most up-to-date information to plan our operations. But again, overall, we're seeing across the UK, Germany, Scotland, Ireland, it's the relationships that we're trying to promote. We're trying to promote good relations with our fishermen, and trying to make sure that we're all working together, because at the end of the day, we have to respect that there's fishing grounds there and that we're coming into their territory, and we have to be able to work together. And sometimes that's more challenging than others, but certainly we find we're getting better at it. And it's a difficult position for our clients as well. So certainly a challenge. I know, Cian, you've had an interesting year across the geophysics campaign trying to deal with different array of fishermen, and I think it's been quite a success. So.
Yeah, I think it's worth saying when we're noting fishing, it's often static fishing gear, so pots, tangle nets, etc.
Mm.
I suppose so. What happens is if we're towing equipment, we can tangle it up, we can lose our equipment, but also then equally we can destroy their pots. So we try as best we can to stay out of each other's way. Difficult though when you're towing something at night. So we try and help get the client to do scouting surveys for fisheries and engage with those fishing communities early through a fisheries liaison officer.
Yeah. Very good.
Oh, sorry.
Yeah, so the final element here is the redundancy, as I mentioned previously. This is a challenge because we need to make sure that we're offering full redundancy across all our sensors for our clients. And this certainly seems like one of the most popular arrangements where we spoke previously of the seabed frame pointing upwards from the seabed, the wave rider on top to accompany the main product itself. So again, I just wanted to mention it again here because this is kind of what we see as the most, I suppose, popular system, and it's just to ensure that our client is getting full data sets across, as much as possible across the campaign. So they would have to be serviced as part of our servicing campaign. We would go out, do our bits on the buoy. We'd also do download data from the smaller product there in the middle, and also we'd have to pull those seabed frames using acoustic releases, pull them up, download the data, put in new batteries, and redeploy. So that's part of our 6 monthly servicing strategy. So, yep.
We might just touch. We're nearly there. We might just touch briefly on the technology and innovation in offshore surveying. So I suppose just to give a kind of a rough overview of our data products in a bit closer detail. The image on the left here is sub bottom profile data showing various horizons. And I suppose then on the right you can see a German submarine. So often we'll use known targets such as shipwrecks to do calibrations and patch tests. So we've actually found uncharted wrecks. We found a 70-meter wreck last year in the middle of the North Sea when we were doing a fiber optic cable route. So you come across some very interesting stuff. I think, Kevin, you had a 40-foot container mysteriously come up as well.
So yeah, in a recent project off the East Coast, just a very pointy object was coming out that was half covered with sand and clay and whatever, but certainly it looked like the edge of a very large container. So unfortunately, we didn't claim salvage on it yet, but yeah, be interesting to know what's inside it. But yeah, we come across an awful lot, like as in, I think, yeah, you can see here actually, this is interesting. I hope that video is playing for everyone, but what you're seeing here is our data products. That's about, we're saying 4 to 6 meter waves, okay, estimate. But as I said previously, what we found is that from recent storms is that we've recorded wave heights of 20 meters plus, which is phenomenal. And it's unbelievable data to be getting, but it's also, I suppose, an indicator of the climate we're in terms of the West Coast, whether it be Scotland or Ireland. But the data that we're able to get is phenomenal, and the boy is able to survive in that also. But again, it's put into question a whole load of design and connection points that what we've traditionally been using is kind of design parameters of 1 in 50, but the current record-breaking storm and wind speed and wave heights have really opened our eyes that this needs to go probably a step further. And that's a decision for us to have a discussion with our clients. But again, it means bigger product, bigger mooring, bigger chain, and a more redundant product. But yeah, it was really interesting. We have a couple of workshops on it, and you can see the record 100 miles an hour wave height that was recorded. It just it's very interesting when we're compiling multiple data sets across different projects and watching the weather move past. So to me, that's probably a very large way to everyone there on the video, but there's much larger out there, unfortunately. Again, this is just some snippets from the data. So as I said, the windrow or the windrows diagrams here, which are on our monthly products. We also here on the black kind of box here at the end, there's kind of, these are kind of a system of buoys that are at, say, the mouth of an estuary. So IDS monitoring also support any of the construction activities regarding sediment or barge operations in terms of monitoring sediment, in terms of the dispersion of say whatever's come up the seabed from dredging. So that's something that we're very interested in. Also, again, the other ones are more depth sensor, wind direction, some offsets, and also some of the frequency in terms of the wind speed there on the right. So again, if you want any more images of the data product, we can certainly give them, but we'd be here all night if we went through everything. So that's just a flavor of kind of what we're doing. So I think that's it, Cian, is it? We're close enough.
Lastly, I suppose this is just another innovation that our processing team are working on. I suppose when you're doing a cable route survey, you know, one cable route that we had was almost 700 kilometers long and 500 meters wide. So you can imagine how many boulders you'd find in that kind of space. And traditionally, you have to manually pick each boulder. So you have to size it and actually tell the software that it is a boulder, in fact, a boulder. So we're using automated AI boulder picking software. But not only that, I suppose, normally you use a side scan to pick boulder contacts, and what that does is it clears the way for the cable. Basically, you don't want to be routing it through a boulder field. But we usually use a side scan, which is a towed piece of equipment, and the positioning is very accurate, but less so than the multi-beam. And also, you can tow the multi-beam in kind of more marginal, or sorry, you don't tow the multi-beam, you can use it in more marginal conditions. So you can see here, the guys have derived boulder contacts using multi-beam data, which wouldn't traditionally be done. Instead, you'd have side scan, which is the orange box below. And then they've kind of taken it one step further, and they're trying to determine the scour effects from the hollows around each boulder using the multi-beam data. And so you can see the rows below determines the actual flow direction and amount of scour on those actual boulders. So using the features to kind of give the clients a bit more information. So yeah, it's a better system because multi-beam it's motion compensated as much better positioning. So that's something the guys are working on in the office. It's very exciting, and they're due to release a scientific paper on it soon. So I can't say too much more, but that's what they're working on at present.
Yeah. And finally, on the metocean side, I think there's a few things like motion compensation, a big focus on AI, and kind of improving the products, pushing the technology as much as possible, because it's a competitive market. And I think we deployed on the stage 3 campaign now, which is for a research project, but we'll join, I think there's 4 or 5 other companies in the world who will have a stage 3 certification or accreditation. So we're hoping in a few months' time we'll have the same certification, which will certainly open us up to more worldwide markets. So that's the big push and innovation for Green Rebel metocean. So yeah, sorry guys, we're gone 7 minutes over, I think, so apologies.
You're okay. Look, guys, fantastic presentation. Thank you very much.